Hello, everyone. I am so excited and honored to be sharing with you our mixed use multifamily project in the 2020 Solar Decathlon Challenge. The team, right from the beginning, was driven to involve in a project that can have a direct impact on the lives of people. This quote here by Oscar Niemeyer resonates the ethos of our team. It states, "The architect's role is to fight for a better world, where he can produce an architecture that serves everyone and not just a group of privileged people." Our project tries to serve almost 144,000 young adults diagnosed with the autism spectrum disorder in the state of New York. Located in upstate New York, Baldwinsville is about 15 miles away from Syracuse, and that is where we start to make a difference. So, allow me to introduce to you our home at Smoky Hollow. Our residents include 11 young adults with ASD and 5 families who would act as caretakers and neighbors. When we met with our parents and various stakeholders, we understood what this project meant to all of the people involved. It is a passion project, not just for us, but for all our industry partners, because this project is for a cause greater than all of us. Even though we could have worked on many projects, we chose this project with Christopher Community because they gave us the opportunity to create a real change, not only locally, but on a much larger scale. Even though they did not have prior green building experience, their passion towards creating meaningful architecture drove ours. Being the building manager and developer, they helped guide the team through various stages of the project. You'd hope that there would be suitable infrastructure in place, right? However, the team was surprised to find out from the parents that there are almost no assisted living communities in and around Syracuse. Imagine being a parent who has to travel more than 100 miles to find a suitable home for their child. We knew that we had a project in our hands that could disrupt the system and improve the lives of our residents, including Maggie and Mike. To help us realize this dream of our residents into a reality, we consulted Dr. Andy Lopez Williams, a forensic neuropsychologist who specializes in behavioral health problems, to assist the team in making responsible design decisions. In order to create the most meaningful change, a multidisciplinary team composed of 22 undergraduate and graduate students came together and volunteered to join this cause. And so began our journey on this project. I am with Dimitra.
I am Kyle Sluzarchik.
I'm Lucas Farmer.
I am Jean-Claude Regano.
And I am Heather Warren, and we are Syracuse Energy Efficient Design, or SEED. Our logo here represents everything we have been designing for over the past few months, including our clients on the autism spectrum, durability and sensory safe design, net zero energy goals, and health and well-being, all with a focus on biophilic design. We worked extensively with our various stakeholders to create a framework for design that revealed the issues and highlighted strategies for tackling them, through which we determined 6 main design goals for a successful project. Throughout the presentation, you'll see icons referencing this framework on each slide, showing we integrated these elements into every part of our project development. We also closely follow a number of codes, standards, and guidelines for design to satisfy needs for this competition, our building owner, and our occupants. Our main focuses were Passive House, LEED, New York State Building Code, ADA compliance, and ASD design guidelines. With that, let's take a look at our home at Smoky Hollow. Baldwinsville, like much of the Northeast, has extremely cold winters and very warm summers. Predominantly, the winds come from the southwest and the east. Our site lies in a community-oriented suburb, directly neighboring another Christopher Community project, St. Mary's Apartments, which is an elderly living community. Located nearby are the town's schools, reinforcing the feeling of safety and stability a family-oriented town provides. This site is also within a 15-minute walk of both public transportation and a supermarket, making this a convenient and accessible site for residents. Taking advantage of the elongated building site, we created a simple bar-shaped massing to maximize the south-facing facade. We then shaped the massing for optimal solar conditions, allowing for as much comfortable and natural light to enter and heat the building as possible. We next implemented a greenhouse and a trome wall on the south facade, carved out nooks and entryways to create safe spaces for residents, and designed the roof to both mitigate and take advantage of the sunlight. Throughout the design of this project, we took considerations inside and outside our building to achieve sensory safe design, ensuring residents will feel safe and comfortable here. The floor plan itself is fairly predictable, making not only an easy to navigate building, but also reducing any potential to overwhelm residents while making their way throughout the space. The long, clear sightline hallways highlight the clarity of this plan. The first floor houses all of our one-bedroom units, as well as the Christopher Community's offices, a large central gathering space, and a sensory room for residents, which helps them regain focus and improve cognitive abilities. Upstairs, you can find all but one of our two-bedroom units. These upstairs apartments are incentivized units in which the caregivers will live. Small nooks carved along the corridor give residents the choice between a semi-private space and moving to the main gathering space for more social interaction. Here, the double-height ceilings not only create architectural hierarchy, but the parents of our residents specifically requested them due to their ability to help ASD adults be more lively and active. Our greenhouse creates a natural oasis where gardening can provide mental health benefits to the residents. It also works in tandem with a trome wall to contribute to the passive heating strategies indoors. Our home at Smoky Hollow takes full advantage of natural light within the building. The south-facing clear-story windows allow diffuse light to enter the corridor and the north-facing units. The roof overhang allows for direct winter sunlight to enter the building while blocking unwanted summer sun, using the reflectivity of the ceilings and the walls to carry light throughout the building. Furthermore, creating an aesthetically calming environment is important for the building experience of all of our users. Skylights bring natural light into the double-heighted spaces, and we create visual connections to nature through biophilic design. The building materials also reinforce this calming aesthetic. The units are designed modularly, so they are easy to adapt in size and scale depending on the intended number of occupants, making the units easily replicable in future projects. Moving outdoors, there are plant beds visible from each unit around the building. Our farming area is to the west of the site, while venturing east leads you down a winding garden path invoking gentle sensory stimulation, the perfect environment for individuals with and without ASD. We left the existing forest area to the south untouched. Our site doesn't just provide a pleasant experience, though. Trees scattered throughout the site provide shade and noise cancellation, but they also contribute to passive design strategies by allowing a cool breeze in the summers while blocking harsher winter winds. Short grasses can mitigate rain and storm water, and strategically placed planting beds featuring plant life native to the area keep rainwater away from the site foundations. Grasses along the side of the driveway and parking lot collect rainwater runoff, which we collect with storm and gray water to filter and reuse as irrigation for our farm and greenhouse. Not only does this preserve water, but in the event of a shortage, our ability to reuse water will allow our building to continue to supply its own irrigation. Furthermore, our home at Smoky Hollow, while connected to the grid, is not grid dependent. Should we lose power, our solar array has the ability to serve the electrical needs of the building on any day with appropriate sunlight. However, if the power were to go out when adequate sunlight isn't available, we also have a backup generator that can power the essential needs.
We as a team believe implementing systems aimed at increasing efficiency and comfort will allow our home at Smoky Hollow to be the best environment possible for our residents. For example, the excess heat generated within the greenhouse is able to flow through an adjacent trome wall, allowing free heat generation during the coldest winter days. So much so that the building would require up to 2 tons of cooling in the adjacent space. Using Train Trace 3D Plus, we confirm that the trome wall allows us to reduce the workload on our HVAC systems. This reduced workload gives us a better EUI and brings fresh air in from our greenhouse, keeping the residents comfortable. With this passive design, our building obtains an EUI of 26.7, and without it, our building would have an EUI of 53.4. Since the Syracuse winters are so cold, we chose a heat recovery VRF system to supply the 20 tons of heat needed for our building, and transfer heat energy from the common space to other areas of the building. Our heat recovery VRF shown has an integrated energy efficiency ratio, an IER of 23.2, while typical systems earn a mere 20.5. Our team also chose a central ERV, reducing penetrations from 17 to just 2. All of the exhaust and supply ducts have been sized accordingly to follow ASHRAE 62.2. In an enclosed living community like this, where contagious disease can spread quickly, these kinds of systems ensure clean air will reduce the risk of a building-wide infection. The bathroom exhaust connects to the ERV, which tempers incoming supply air. With the reduced penetrations, we were able to obtain 0.6 air changes per hour at 50 pascals, which is the Passive House recommendation for air tightness. There are also multiple duct pressure sensors in kitchen range hoods to maintain ventilation performance despite changing duct pressures. Now, imagine Maggie sitting in her room, enjoying the things she loves most, like her cat Oreo and loud music, while Mike, on the other hand, enjoys reading silently in the comfort of his room. These activities call for different sound environments, so we make sure that these sounds are isolated within the partition walls while having a sound transmission class of 63 and our hallway walls having an STC of 55. As for the ceilings, we decided to use 2x10 wood joists with noise-reducing insulation, receiving a value of 58. Foam wedges were added in the sensory room for additional noise diffusion. Our building's wall system not only meets New York State International Energy Code conservation minimums, seen here on the left, but goes above and beyond with an additional layer of thermal protection. We combat thermal and hydrothermal issues by using a continuous Intello smart vapor barrier, zip sheathing, a continuous air barrier, Siga Wiglove flashing at the exterior, and Siga Rasan. To further ensure a compartmentalized wall assembly, sealant will be applied to the connections highlighted in red, ensuring there is zero leakage in the wall assembly. Understanding the winters in Baldwinsville, we ran a WUFI model to project our moisture content within our exterior walls and roofing. This model confirmed that we are well below the threshold of water content within our walls. Additionally, using the Therm software, we were able to show the thermal effectiveness of our foundations, our connections between floors, and our connections to the roofing. These were plotted along with dew point to ensure the air barrier and vapor barrier temperature never falls below 40 degrees, therefore resisting hydrothermal fluctuations and moisture buildup. For the peak demand of 250 gallons of hot water needed, the team has selected 2 Sanco 2 heat pumps, which are to be placed on the exterior wall outside of the mechanical room. Instead of using standard refrigerants, this heat pump uses CO2, which allows it to run up to 4 times more efficiently than most standard heating solutions. The heat pump is connected to a centralized plumbing plan, minimizing the cost and hassle of installation. We plan on consulting contractors to determine the best way to route the pipes to minimize heat loss. Gray water from the plumbing fixtures collects in a central storage tank, which is then filtered and used for irrigation in the greenhouse. For added water savings, we have connected this storage tank to our rainwater collection system. Why such a system, you ask? This system can save up to 660,000 gallons, equivalent to the size of an Olympic swimming pool, annually on irrigation alone. We believe that the collected water can be used around site for most, if not all, of the irrigation needs. For our team, it was essential that we meet ADA compliance for the families that will be making memories at our home at Smoky Hollow. We went above and beyond, making sure each room meets this code while remaining highly efficient. With our fixtures using 50% less water than standard fixtures, this beats the EPA's water sense standard by 45%. These high-efficiency fixtures, when compared with the New York State average cost of water, can save us upwards of $850 per year.
Natural lighting is very important for occupant well-being. These analyses were done in DIVA to assure that every unit receives a comfortable amount of natural lighting throughout the day. For artificial lighting, the team selected Brilli Lighting. The Brilli system provides high-efficiency LED light fixtures that have the ability to change Kelvin levels from 2200 to 5000 K, the difference between which is shown in this side-by-side render here. With connectivity to the building automation system and to daylight sensors, the system can seamlessly adjust the brightness and Kelvin levels to match the natural progression of the sun throughout the day. This mimicry of natural light has been shown to have a positive effect on occupants' circadian rhythm, promoting a healthy sleep schedule and improving focus. It's important to note that we changed the system from the one in our project report due to further research that showed the old system didn't have required certifications. Now, for on-site energy generation, the team chose a rooftop solar photovoltaic array. The site will have construction in the future, so minimizing the footprint of our home at Smoky Hollow by putting the panels on the roof is important. The panel used is a 72-cell frameless bifacial panel from Prism Solar Technologies, with a white roof coating underneath to maximize reflected solar collection. Prism Solar is a New York-based company that specializes in panels specifically designed to take more advantage of the solar conditions here in New York. A microgrid could be established with the planned third building and St. Mary's Apartments, which would improve energy reliability as well as reduce the cost of living for St. Mary's. The building is grid connected and will take advantage of National Grid's net metering program. So how do all these energy performance measures affect the overall rating of the building? Well, upon conducting a HERS index assessment using Ecotrope, the team calculated an average HERS index of -20. The one-person corner unit with 2 exposed exterior walls was our worst case, with a -14. These values differ from our report submission due to changes in the ERV flow rates and wattage. When on-site renewable energy is emitted, the building still has an average HERS value of 38.7. The building automation system the team's chosen is the Honeywell WebS-AX. This system was chosen for its flexibility to control the energy-saving systems the team has incorporated, such as the greenhouse Trom wall dampers. Comprehensive submetering, managed by the BAS, will improve efficiency of building systems and help with peak demand shifting. Plug loads will be intelligently controlled by the BAS, cutting down on phantom power drain. Designing for residents with ASD presented some interesting challenges. For instance, some parents let us know that standard fire alarms can cause panic and can also be overwhelming. The team selected a specialized alarm system that combines voice alerts and bed shakers to alert residents during an emergency. Also expressed by parents, when it comes to appliances and thermostats, simple physical controls are best. Here are some of the appliance selections we have made with the goals of energy efficiency, BAS connectivity, and simplicity. Durability of materials is very important to Christopher Community because their business model relies on low operational costs. Reconciling this with environmental requirements, the team's selections included Forbo Marmelium sheet flooring, Broadway carpet tiles. Both flooring selections are Green Label Plus for indoor air quality certified and are rated for heavy residential traffic. They also both have a lifespan longer than the net zero payback of the building.
The low energy use and durable material selection were mainly for our clients' benefit, but they also helped us reduce our carbon footprint. New York State has pledged to be net carbon neutral by 2050. We want to be an example for others to show how we can reduce our carbon emissions from our buildings. Embodied carbon for our home at Smoky Hollow was calculated through One-Click LCA, which listed it in the lowest category group with 155 kilograms of CO2 embodied per meter squared. The project plan had 509 tons of carbon sequestered biogenetically within the building and the site. After accounting for the sequestered carbon, we are left with negative 99 tons of carbon embodied during the life cycle for this project. We hope our home at Smoky Hollow will lead the transition to low carbon construction in the years to come. Low embodied carbon was actually one way we reduced the initial cost, too. The team found 3 significant incentives from the New York State Energy, Research, and Development Authority, also known as NYSERDA. NYSERDA's largest incentive was the Buildings of Excellence competition. Through this, NYSERDA hopes to promote resilient, low-carbon building in New York State. To get an accurate estimate, we used the Revit plugin AgaCAD to add a wooden frame to our walls. We had an uncommon roof and an uncommon floor, so we estimated for those components. We learned that sometimes the original plan doesn't work out. In those cases, an accurate estimate will do. Our S-means data was used for an overall estimate for the project. Some unique elements, like the greenhouse and the bifacial solar panels, required us to get quotes from their manufacturers. The MEP pricing was calculated using square foot allowances based on information shared to us from Jacobs Engineering. The resulting cost for our building comes out to $6.2 million, or $270 per square foot. But this was an estimate. We predict the actual cost will be between $5.9 and $6.8 million. In our greenhouse, residents can use the compost from the kitchen to garden. Gardening can be hard work, but it can be beneficial with a feeling of independence and responsibility along with many other health benefits for the residents. During these times, when we're all stuck in our homes, I bet anyone would like to have a greenhouse to escape to. The greenhouse quote from Florian Solar Products is about $55,000. With 3 harvests a year, it can produce $26,000 worth of produce every year. This creates a 2-year payback based on local grocery store prices. The greenhouse can also be an opportunity for community development. Seed, along with local nonprofits, can teach classes for the residents to learn sustainable gardening techniques. Helping the residents garden can be an excellent community service opportunity for the locals. Produce from the greenhouse can be used to feed the residents, for the local community dinners, or even sold as local produce for the farmers market. The solar panel system included will have an upfront cost of about $350,000, but will pay itself off after 9 years. At Christopher Community's recent project, Harborbrook Apartments, average energy costs per person are about $320 per year. Seed's net zero design will instead produce a surplus of about $32 per person annually. This creates a total savings of $7,350 each year just from energy. The initial price estimate for a traditional code-compliant building on the site would be $220 per square foot. This is 23% less than our net zero estimate with $270 per square foot. To satisfy our client, the net zero payback must occur early in the life of the building. After accounting for the total incentives, the difference between a net zero building and one that is just code compliant comes out to $572,000. In addition, considering annual costs for energy and income from the greenhouse, our home at Smoky Hollow will create a savings of about $34,000 every year. The payback period for net zero will be 17 years.
Our home at Smoky Hollow is designed based on the vision to re-innovate the building typology associated with these individuals. We were heartbroken to see that until the early 2000s, most people on the autism spectrum were institutionalized. Imagine this being your home, and now imagine living here. Our project does this by catering to the demands of the occupants at the forefront of all our design decisions, be it having clearly designated circulation throughout the floor plan, or having flexible common spaces that adjust according to the mood of the residents. Our residents decide if they want to watch a movie or spend the afternoon having lunch with their neighbors. We use concrete earth tubes to cool our interiors in the summers. By integrating this into the architectural language and working with Argus Engineering, we determined the earth tubes could add 1.68 tons of cooling to our building. That meant almost 10% of our cooling load is absolutely free. In addition to that, we also try to reduce our furniture costs by using reclaimed furniture, saving the client over $10,000 and helping us reduce our carbon footprint. With the modular design of the units and the self-sustaining nature, this building model allows for seamless transition across a variety of scales. It is not only the energy efficiency, but the research basis of this design that gives it the potential to be replicated across similar climatic zones. Our model, when compared to a baseline standard ASD living cost, reduces the expected cost of living by about 50%. Upon meeting our residents over multiple interactions, our passion for making a difference in the lives of our residents is what drove our project. We are doing this project for those parents who felt that they have no options, and for the 90% of those individuals who do not have access to assisted living facilities. But most importantly, we're doing this project to make a difference in the lives of our residents. We called it our home at Smoky Hollow because this is not just another net zero project. It is a family, a community that will live together, fulfill dreams together, and be a role model for self-sustained community living. And I am so excited to share that our home at Smoky Hollow is breaking ground in 2022. Thank you.